Hi guys, in this video we're going to have a look at how to work out the surface area of a cone. So we've got a few simple examples just using the formula, and then we've got some trickier ones where we go back and try and find the radius and different bits like that. So it does get quite tricky, especially at the end. There's some very juicy questions, so definitely stay until the end and have a go at those yourselves. So the formula to work out the surface area of a cone is pi r squared plus pi rl. Now the pi r squared, you might recognise that as the area of a circle, and that's because the base of a cone is a circle. So the pi r squared refers to the base of the cone. This pi rl is the surface area around the top bit here, and r is the radius and l is the slanted height going here. Now I've included h here to be the perpendicular height. That's not needed for the formula, but it does come in handy later on, so I just wanted to add that on there as a heads up for later. So that's the perpendicular height, but we'll be using, part of the formula, the slanted height here. Okay, so let's have a go at some examples and see what we come up with. So if I want the surface area of this cone here, I'm just going to substitute the values straight into the formula. So pi times the radius, which is 7 squared, plus pi times the radius, which is 7, times by L, which is this one here, which is 12. So just put that straight into your calculator. Now what you might want to do, which I highly recommend actually, just to save any potential errors, is put that bit in brackets and then put that bit in brackets. So you're just doing that bit, and adding them together, just so your calculator doesn't get too confuzzled with bid mass. It should be okay, but just in case. So pi times 7 squared, close the bracket, plus pi times 7 times 12, close the bracket, and we are left with 133 pi. So obviously if the question says leave it in terms of pi, that's what you would do. However, if it says to round it to something, we press the SD button, which means we have 417.8318, etc., etc. So round it to whatever the question asks. I'm going to go one decimal place. So 8 is the first decimal place. 3 tells me to round down. So 417.8, and it's the surface area, so it'd be centimetres squared. Excellent, first one done. Let's have a look at the next one. Exactly the same thing, just substitute it straight into the formula. So again, I'm going to stick it in brackets. So I have my pi times by the radius squared, and then I need to add that to pi times the radius times by the slanted height there, which is 15. And again, I'm just going to stick that straight into the calculator. So pi times 4 squared, close that bracket, plus open bracket, pi times 4 times 15. Press the equals, so I have 76 pi. If I press SD, it comes out at 238.7610, etc., etc. So to one decimal place. This time the 6 will round up that 7, so 238.8 centimetres squared. Okay, so this one, next one, is slightly different. It's broken up into two parts. It says work out x, and the reason it says work out x is because part B says work out the surface area. Now I can't work out the surface area without that slanted length here, so I do need to work out x in part A before I can go and do part B. And this is where the perpendicular height comes in handy, because you may have already noticed that forms a right angle triangle. So I'm just going to re-sketch that. So there's my right angle triangle. In which case, to work out this missing length here, we can use Pythagoras. So I'm going to work out the area of this. So this side here is 12, so 12 squared is 144. This side here is 5, so 5 squared is 25. In which case, when you add them two together, you're going to have 169, and the square root of 169 is 13. So x will equal 13. If you want to use Pythagoras using the other way, so 12 squared plus 5 squared will equal x squared, so 169 equals x squared, So x will equal the square root of 169, and again you get the answer of 13. So I'll just put that there for our diagram. So just use a bit of Pythagoras to help you find that slanted height. It does every now and again come up just to see if you can do Pythagoras as well as the surface area of a cone. Once we've got that, next bit's really easy. It's the same as these two. We just stick it straight into our formula. So pi times the radius, which is 5 squared. And then add that to pi times the radius, which is 5, times by the slanted height, which we just did was 13. So let's put that into our calculator. Pi times 5 squared, close bracket, we need to add them. Pi times 5 times 13, and it comes out at 90 pi. And again, if you press the SD button, I'll have to round this straight away because I haven't got space to write it out. Obviously in the exam you would write it out. So 282 point, and then that 4 would round the 7 to its down, so it would stay as a 7. Okie dokie. So there we go. This is just an example of how to find the slanted height using a bit of Pythagoras. So let's carry on and have a look at some more. So here we have the same problem, where we need to work out x, and then we need to work out the surface area. So let's have a go at that. So again, I'm just going to draw my right angle triangle, which is this bit here. So this is 6 and this will be 10. So area of 6 squared is 36. Area of 10 squared is 100. And then we're after the hypotenuse, so we need to add them together, which is 136. And the square root of 136 is 11.66. 1, etc., etc. Okay. So again, you can do the other Pythagoras as well. In fact, let's just quickly do it. So we're going to have 10 squared plus 6 squared equals x squared. So 100 plus 36 is 136 equals x squared. So x will equal the square root of 136. So x equals 11.661, etc., etc. Okay, so either one you do, the diagram or algebra is absolutely fine. Now you've got two choices here. You can keep that number on your calculator, or you can just treat x as the square root of 136. Because we don't want to round this yet until the very, very end when we deal with the surface area. So you've got two choices there, either like that or like that. So when we now work out the surface area, we can now plug it straight into the formula. So pi times the radius, which is 6 squared, add pi times the radius times by this 11.661. So again, I've kept it on my calculator, so I could use that, or I could use the square root of 136. I'm going to write it as the square root of 136, but I could equally do what I'm now about to do on here. So keeping that on my calculator, I just type it in as I would do normally. So pi times 6 squared, close bracket, plus bracket pi times 6 times, and I use the previous answer button to use that decimal. Now of course if you did cancel that, don't worry, you can just type in the square root of 136. That would work just as well. And I press SD. Oh, sorry, I don't press SD, I just press equals, and it spits out the decimal 332.91904, etc., etc. So to one decimal place, 1 tells me to round down, 332.9 centimeters squared. So it's just an example where that's not as nice. Okay, so here we go then. If we're told the surface area, how can I work out the radius? Now this is tricky. It will involve solving a quadratic via factorizing. So if you're a little bit unsure of that or can't remember how to do that, definitely check out my video on solving quadratics via factorizing, because it's going to be what we use now. But whenever we do go backwards, we do exactly the same thing. We substitute everything we know into the formula. So let's substitute all what we know here into the formula. So we have pi times the radius squared. Well, the radius is x. And then we need to add pi times the radius. Well, the radius is x, times by the slanted height there, which is 18. And that's going to equal the surface area, which we're told is 40 pi. So all I'm going to do is just simplify all of this. So pi times x squared is pi x squared. Pi times x times 18 is just 18 pi x. And of course that equals 40 pi. Now the first thing I'm going to do is every single one of these has pi. So I'm going to divide both sides of this equation by pi to get rid of that, which should make it a little bit easier. So x squared plus 18x equals 40. Now hopefully you can start to see why I said solving a quadratic by factorising, because we have an x squared, an x and a number, but whenever you do solve it needs to equal 0. So I'm now going to get rid of the 40 from that side, and obviously if I do that I do it from the other side as well. So I'm left with x squared plus 18x minus 40 equals 0. Once you've done that, you can now factorise this. Now, if it was a calculator, you might have to use the quadratic formula, but if it's non-calculator, or to be fair, even if it is calculator, they might even still do it this way where you can factorise. So let's do that. So I obviously have my x squared, I have my minus 40, x times x gets me my x squared. So I need numbers that multiply to get to 40, but add to 18. Where can I write that? Let's just go next to it. So obviously 1 times 40, 2 times 20, nope. In fact, there we go, I can stop. 2 times 20, so I can use 2 and 20 to get to 18, plus 20, and then minus 2, so plus 20 and minus 2. Okay, so minus 2 times by 20 gets me minus 40, and 20 minus 2 gets me plus 18. So there we go, factorised it. Brilliant. So let's just write that out. Okay, then we need to solve this. So again, imagine each bracket equals 0. So in this case, x will be minus 20, because minus 20 plus 20 is 0. If this doesn't make sense, definitely check out the video I did on how to do that. So that's solving quadratics by factorising. And x here will be 2, because 2 take away 2 is 0. Now, in the context of this question, it cannot be minus 20, because you cannot have minus a radius. You can't have minus a length. You can't go into negatives. So that answer is nonsense in the context of this question. So in fact, our answer in this case is x equals 2. So the radius would be 2. I'm going to do exactly the same thing with this example, just so you can see it again, step by step. Obviously, if you want to give this a go by using this and then just fast forward in to check your answer of what I'm about to get, that's absolutely fine. So if you want to pause the video and give it a go, by all means do so. But let's get cracking and do it together if not. So substitute everything in. So pi times the radius, and again, is x squared, plus pi times radius, which is x, times by a slanted height, which is 13, and we're told that equals 48 pi. So again, a little bit of simplifying like we did here. I'm just going to write it here so I have a bit more space down this one. So that's pi x squared plus 13 pi x equals 48 pi. Just like I did here, pi's are in everything, so get rid of the pi by dividing everything by pi, like so, which leaves us with x squared plus 13x equals 48. Again, to solve a quadratic, it needs to equal 0. So I'm going to minus 48 from both sides. So x squared plus 13x minus 48 will equal 0. And again, factorise this. So here's my grid, so x squared and minus 48, obviously x times x gets me x squared, and numbers that multiply to get to 48 and add 13, So we're going to have 1 times 48, that doesn't quite work. 2 times 24, nope, that won't work. 3 times 16, that will work. 3 times 16, so plus 16, take away 3. So 16x, take away 3x, that's going to give me my 13x. Again, if you're unsure how to factorize, just factorizing itself or that method, just look at factorizing into double brackets and that should help you. And then if I write that out, I have x plus 16 in one bracket, x minus 3 in the other equals 0, in which case, I'll just move it over here, x will equal minus 16 to make that bracket equal to 0. X equals 3 to make that bracket 0, and just like over here, you can't have a negative radius, so minus 16 is out, so the answer there is x equals 3. Okay, so there we go. There is the surface area of a cone with some very juicy questions at the end there, going backwards and finding out the radius. Hopefully that helps, guys. Thanks for watching. Cheers.